Hello, everyone. So, my husband went into the office today. He's been working from home for the past year. He went in the office today, and then of course my sitter calls me like 20 minutes ago and says she can't come. So I have both of my kids floating around right now. So if you hear screaming and things of that nature, that's just what that is. So as far as class goes today, I was going to try and lecture ahead, but I think it's going to just be a little bit too crazy with my kids right now. So what we can do is practice, specifically working on the nomenclature lab. So lab 7, because yes, we are in chapter 5, but the lab is lab 7. So don't do lab 5 yet, do lab 7. So that has to do with all the nomenclature stuff. So we're just gonna work on that. So if I could ask somebody who hasn't filled out their lab, if there's anyone who hasn't filled out their lab, if you could take a picture of the lab and email it to me, because I don't have my lab manual on me. I don't know where my lab manual went. And it's kind of hard to get a new one. So, I mean, I have the lab almost memorized, but not completely. So if there's anybody that can do that, that would be great. And then we can sort of look at it together. And then hopefully we can get through some of it, most of it, so you don't have too much. As far as, let's look at our syllabus. As far as our syllabus goes, so this week you will have the nomenclature lab, chapter 7. You'll have quiz, I know quiz 6, it's so confusing, but it's the nomenclature quiz. And then you'll also have the chapter 5, mastering chemistry. Okay. Let's see. So if you can email me a picture of it, can you just throw in the chat that you can get that to me? And that would be super helpful so that I know that it's coming my way. Sorry, I do not know where that lab manual went. Oh, working on it. Thank you, Elizabeth. All right, Elizabeth is helping me out. Okay. She's helping me out, which in turn helps all of you out, because then we can try and get through most of this lab. Hold on one second. Gabby? Can you please let Turkey out?
Which lab did you say it was? You're muted.
Lab 7. So it is like the first page is going to have some stuff talking about Lewis dot structures. And then there's these like matrices or like graphs where you have a metal and a non-metal. And then the following 2 pages will be like just a list of formulas that you have to name and then names that you have to write a formula for. So with that lab, while you're looking at it, if you've got it out, you are not going to do the very first section. So Carrie asked me the other day about like the Lewis dot structure section, which is the very, very top of it. We aren't going to do that because it's more work than it's worth. But we will be doing the rest of it, so just bear with me. And if you want, while we're hanging out, you can start working on the first page. So the first page, there are 2 boxes. One is a metal on the x-axis and a variety of non-metals on the y-axis. And you have to pair up the metal with the corresponding non-metal. For the first part, you are going to flip-flop charges to come up with the correct formula. For the second box, it's the same metal and non-metals in the same positions, but you have to name them. So if you want to get started on that, and I'll chime in a few minutes here. Awesome, Elizabeth, thank you. I just got it, so I'll pull that up here. I need you to watch baby. All right, so I've got it. So let's take a peek. So this is what the first part should look like of the lab. So again, you're going to skip this here. We've got a variety of metals. The important thing is that, they have their appropriate charges. You can see down here at the bottom that it's copper with a 1+. So it's saying in this one to use the copper with the 1+. Looks like it won't let me annotate. All right. So with this one, we have K+ and Br-. So if I flip-flop charges there, it's not going to let me draw on it. It's a 1-to-1 ratio, so we should have 1 potassium for every 1 bromine. That's one of my daughters back there. She's just going to creep in on occasion, I think. So it should be KBr. This next one here, we've got calcium with a 2+ and bromine with a 1-. I'm going to try and open this up so we can. So we've got C. It's just not wanting to work today. Ca with a 2+, and we're combining it with Br with a -. So we'll flip flop, and we should have 1 calcium for every 2 bromines. The next area I want to work is, let's look at gallium, where we're combining it with this thing over here, nitrate, NO3-. So gallium is a 3+, nitrate is NO3 with a - charge. So I'm going to circle the polyatomic ion because I don't want you to get the 3 confused with the charge. what is the charge on this overall nitrate? It's a -1. So the 1 is going to drop down to the gallium. So I should have 1 gallium. And then for every nitrate, I should have 3 nitrates. Nope. Nope. Go. So 3 of these. So I'm going to put this in parentheses. And then outside of it, I'm going to put an additional 3 because this has to talk about 3 of the polyatomics. So you'll go through and you're just going to flip-flop all of those. Now, when we get to this section where it's copper with, hold on.
You're muted.
Thank you. Sorry. It's because I didn't want you to hear what I was saying to my daughter. So the copper with the 1 plus, we are going to write it as 1 plus. It gives you that, so go with that number. So we'll flip flop. Cu is going to get the 3, and the phosphorus will get the 1. Okay, so when you're doing that copper stretch here, I don't want you to think, oh, what's its charge? It's telling you the charge. Now, right underneath this is the exact same combinations. The difference here is it wants you to write the name. Okay, so for this first one where we had potassium and bromine, we would just call it potassium bromide. Right. Calcium and bromine would be calcium bromide. Remember that when you're combining with a polyatomic ion, you don't change the name of the polyatomic ion. So we're going to call this potassium. This one here would be potassium nitrate. We don't truncate it and do anything like that. The one thing you do need to do though, in this section, see down here where the coppers are. It does give you the charge of the copper and you have to say that, okay? So you can't just call this copper bromide. You have to call it copper 1 bromide. And because it's copper 1, every single one of these should start with the word copper 1, copper 1, copper 1, copper 1, copper 1. Okay, they are all containing copper 1. You're just changing out whatever the nonmetal is. So I'm going to give you all 2 minutes to sort of sift through that. Just try, you can go in order. If you want to try a couple random ones, do it. And then we'll come back together. And if you have any specific questions on any of those, we can look over them. The trickiest parts I think people have is this column and this column, and maybe the gallium with the 3 plus. So if you want to try some in that area, do that. But yeah, I'll give you 2-3 minutes for that.
I have a question.
Yeah, what's up?
Calcium bromide one at the top. The BR doesn't get the 2 charge for the calcium.
It does get the 2 charge, yeah.
I did.
Ah, there we go. Yes.
Okay.
I was testing your skills, Carrie. I was making sure you were paying attention.
Sorry. Thanks.
Yeah, good. Yeah, that's good. So yes, you definitely will want to switch the charges. All right, so any questions thus far on working with this matrice where you're crisscrossing? So all of these are some sort of metal combined with a non-metal. So we want to balance charges. This one that I do want to talk about, this one, gallium combined with phosphorus. So gallium 3+, phosphorus 3-, flip flop, and we get Ga3p3. But remember, if it's ionic, you can reduce. Okay, so we're going to get rid of the 3s, and it should be GaP. And the name on this thing is gallium phosphide. I take the first syllable and then ide it if it's a ionic. All right, let's look at the next page here. So in this one, this is awesome practice for you because this is like a mishmash of all the different rules. So I've got all sorts of different things here. AgNO3, ICl3, you know, how many do you get? 20, something like that, 25. All right, they're all jumbled together and they're not explicitly telling you like what they are. So the first step with each one of these, what I would do is go through and determine what they are. All right, so I'm going to write these first couple. We've got AgNO3, ICl3, AgNO3, ICl3, MgOH2, and ZnSO4, yeah. Okay, ZnSO4. So we'll do these first couple together. Well, let me see. I'm also gonna skip down. I wanna do number 9 as well. So number 9, FeOH3. So the first thing is to determine what this is. So this first formula here is a metal and it's silver, which is a predictable charge. So this is an ionic type 1. The second thing you want to note when looking at this is there a polyatomic ion? There is in fact a polyatomic ion. So I'm going to put a P next to there as well. So when naming this, I need to say the name of the metal, silver. Do I need to write its charge? No, because it's a type 1, right? It has a predictable charge. Silver will always be silver 1, so I don't need to call it silver 1. The second thing I have to take into account is that there's a polyatomic ion. So I just write the name of the polyatomic ion. In this case, it's nitrate, silver nitrate. And that is more than enough information to get you back to the formula. If you were to just see this thing, could you come back up with that formula? You could, because silver, Ag, is always a plus charge. Nitrate is always NO3-, flip-flop, Ag, NO3. You have now created the same thing. So there was more than enough information there for you. Let's look at the next one. The next one, ICl3. So there's no metal here. These are two non-metals. So this is molecular. There's no charge. So what do we do with molecular things? We do prefixes. We have to specify to the reader how many of each we have. You don't have to do that here. You don't have to say that you have one silver and one nitrate because they have charge neutrality. They'll always come together. They'll always pair in that way. But non-metals, because they're sharing electrons, there's a variety of ways they could come together. It could be ICl3, it could be ICl4. Lots of different things can happen when you're sharing. There's more variants. So we have to say how many E of each you have with a prefix. So we have one iodine. Remember, if you have one on the first, you don't have to say monoiodine. So we're just going to say iodine. And then we have to specify what we've got for the second one. This is chlorine, and there's 3 of them. So what's the prefix for chlorine? Tri, like a tricycle. Tri. And then chlor, first syllable, and we ide it. Trichloride. This next one here, this is ionic. Magnesium is a metal. It's type 1 because magnesium always has a predictable charge of 2+. And there's a polyatomic ion. So with ionic, I'm going to say the name of the metal, magnesium. And because it's polyatomic ion, I just say whatever the polyatomic ion is. This is hydroxide. Okay, in red here, I'm going to write some of the pitfalls that I see with this one specifically. And it's sort of like a microcosm to the macrocosm. I see this a lot. Why is this wrong? Do we need this? Do you need to tell the reader that you have a 2 charge on magnesium? No, it's redundant information. If it is magnesium, it's going to have a 2+ charge. Okay, so that's one pitfall I see. Another thing I see is this. Oh, people love to do this one. Magnesium dihydroxide. Because they're like, I gotta say that there's 2 of those hydroxides. I can't just say hydroxide. One thing to note, we do not use prefixes if there is a metal anywhere around. So do not prefix if the first thing that shows up in your formula is a metal. Also, we don't use prefixes for polyatomic ions. So we're not gonna dihydroxide this. Okay, so we don't like these. I'm gonna cross these out. But I think it's good to see what the common mistakes are. So if that you see something like that pops up, don't do it. Going along, I'm gonna pause for a second and do another one that I see quite often. So I'm gonna put, and this may be one on your sheet somewhere, Al2O3. So if I'm to, I'm pretty sure this is on there. Ionic, type 1, no polyatomic ion. So I'm just going to name the metal aluminum. And the nonmetal, which is oxygen, oxide, aluminum oxide. Is that enough information there to get back to the original formula? It is, because what's the charge on aluminum? Always 3+. What's the charge on oxygen? Always 2-. Flip-flop, Al2O3. The key is to write a name that gives you enough information, but not redundant information. What are pitfalls I see with this, just to kind of coincide with that previous one we did? A lot, I get this, dialuminum trioxide. Why don't we like that one? Don't use prefixes if there's a metal. Prefixes are for molecular. Okay. Another thing, aluminum 3. Sometimes people get really creative. They'll like mix up the errors. Aluminum 3 trioxide. Okay, a couple things wrong here. We don't use prefixes if there's a metal, and we don't need to put the charge in there. Because aluminum is always a 3+. So that is something that could be like in the multiple choice. Like I could give you this and say, you know, name this, and it could have aluminum oxide, it could have aluminum 3 oxide, it could have dialuminum trioxide, and it's testing you on, you know, I'm testing you on, can you use the correct rules in the correct spots. So if you can't identify what it is, if you can't identify it as ionic, molecular, so-and-so, that's going to give you some trouble. Let's go back to those couple that I wanted to show you up here, and then I'm going to give you some free time for this first page, and then we'll move to the second one. Hopefully we'll be able to get through a good amount of it. So this next one here, zinc sulfate. Oh, I just told you what it is. So let's determine what it is first. So it's zinc, which is a metal that's ionic. Change the color. Ionic. It's type 1 because zinc has a predictable charge. I know that it's sitting in the transition metal, but we said that that always has a 2+. And then sulfate is a polyatomic ion. So because it's type 1 ionic, all I have to do is write the metal, which is, in this case is zinc. I don't need to put zinc 2. And then I name the polyatomic. In this case, it's sulfate. I don't truncate or do any changes to polyatomics. So zinc sulfate is more than enough for this. This last one I wanted to do to show you varying charges, just as a refresher. Let me get this one out of the way. Okay, so number 9 is this thing and this thing. This first thing is a metal, so it is ionic. The difference with this metal compared to the other metals is that this is a varying charge. So this is an ionic type 2. So when it's a type 2, we need to put parentheses. So I'm just going to write iron over here. That is my dog, not a baby. Turkey, quiet. Okay, so type 2. And then the other thing that we want to, oh, I'm going to put a parenthesis here. The other thing that we want to note is what this is. This is a polyatomic. Okay, so we got a polyatomic. So iron, and then what is this thing here? This is hydroxide. So this is some sort of iron hydroxide. We need to fill in the charge. So let's go back over to our formula, cut my metal from my non-metal. The whole thing needs to equal 0. Hydroxide, its formula is OH minus. So it's got a -1 charge. And how many of them do I have? I have 3 of them. So it's an overall 3- charge. So you go from what you know for sure to get what you don't know. If this is a 3-, this has to be a 3+ to give us that neutral charge. There's only one iron holding that entire 3+ charge. So that iron will have this entire charge. So iron 3 hydroxide. So I think the hardest thing for people is like when you get it jumbled like this, it's like separating out all the rules. When do I use what, where, how, when? So I do recommend that flow chart that's on the last page of the slides to kind of help segregate what it is that you need to do when. So I'm going to give you guys now an open period of 10 minutes or so, 10-15 minutes to go through as many as you can on the rest of that lab that we've got here. We will do the next page in about 10-15. If there are any that you're really struggling with, go ahead and just circle them, and then we can I can go over them specifically as a group. Okay, so there's quite a few here. If anybody wants me to look over this before you turn it in on Sunday, just get it to me by like Saturday afternoon, and I will like pre-grade it for you before you turn it in so that you can get full credit. Okay. So I will meet back with you all. What are we, 10:04? I'll meet back with you all at like 10:15, 10:20.
May I ask a question real quick?
Yeah. Who is this?
This is Eliana.
Hey, what's up?
I got to class a little bit late today, and then I was not able to make it on Monday. I was
Okay.
just curious about the first part of lab where we're doing Lewis dot.
Yeah, so we are not going to do that part, that very first page.
Got it.
We're doing part of the first page, but this here, just go ahead and cross that off. We're gonna do Lewis Dot stuff in chapter 9, so it's more work than it's worth. You will be able to do the rest of the lab without that.
Got it. Okay. I just wanted to make sure. 'cause I
Yeah,
couldn't-
but you will do this and you will do this. Okay.
Yes, I saw that part. Great. Thank you so much.
Okay. Mhm. Give you all 2 more minutes. All right. So, are there any ones that you would like me to go over or confirm or anything like that? Just you can turn your mute off and say, number 13 or whatever. That's gonna be the easiest way for me to help you out.
Would you do one of the coppers from the first page? Like maybe the
One of the
CU02?
What
Yeah.
number? What number?
From the first page. I don't know. It's on the
is it
first
15?
page. Oh, I'm sorry.
Oh, the
It's on
very
the
first page.
Yes, sorry.
No worries. We're talking about over here.
Yes, on the bottom.
Do you want me to do the formula or the name?
Yeah,
Or
the
both?
name on the bottom, like the CU and the O2.
Okay, so let's do that all together. So we have a combination where we have CU plus and O2 minus, right? That's the box we're looking at. So to write the formula, we'll flip-flop. So bring the 2 for the copper and the 1 down for the oxygen. The name for this thing is going to be copper 1 oxide. Why is it copper 1? Because what is the charge on the copper that we're dealing with in every situation here? Copper 1. So just make sure when you're naming that bottom row, everyone is
Okay,
copper 1.
thanks. I was trying to balance them and it wasn't working. Thanks.
Okay, okay. Other questions? Yeah, either on the first page or on this second page. This is your opportunity to get free answers out of your teacher. So there's one that you were struggling with or you weren't sure of.
Number 11. I just want to double check.
Number
that one.
11, awesome. Okay, so number 11, we've got S2Cl2. So the first thing we always want to do is decide what is it. So this is a nonmetal and this is also a nonmetal. So this is molecular. So with molecular, we use prefixes. We don't reduce with molecular, okay? So we're not going to cut the 2's down or anything like that. So sulfur, we have 2 of them. So we're going to call it disulfur, dichloride. Cool, Kayla?
Yeah, it was just the prefixes that I wanted to confirm on it. So,
Yeah. Confirm, yeah. So both of those will be di.
Thank you.
Other questions?
Number 22.
Number 22. Okay, towards the end. Let's see what we got there. So, oh yeah. So this thing, yeah. Let me just write it out. That's not one that I would necessarily put on a test because that polyatomic ion like doesn't come up a whole bit. What did we say? It was K2 CR2 07. Okay, so the first thing that we see on this is a metal. So this is ionic, and this is potassium. So it's type 1. It's a predictable charge. When you get into a situation where you're like, oh, wow, that looks like a mess. It's not following the rules I'm used to following. Look at a polyatomic ion sheet. All right, this thing right here is a polyatomic ion. Specifically, it's called dichromate. How would you know that? Just look it up online or a polyatomic ion list somewhere, but that we call dichromate. So there is also a polyatomic ion on this thing. So hopefully now it feels a little easier to name. We name the metal, which is potassium. Excuse me. We don't need to say what the charge is on this thing because potassium always has a 1+. So we're just going to say potassium and then the polyatomic ion name. Josie, relax. Hold on, the male person just came. Okay. So I don't know who asked about that one, but does that make a little bit more sense? Yeah. So if you get to a place where you're like, what is that? That's so messy. It's a polyatomic ion. Let's look at, I think there's a couple like that, like number 18. You've got this Ag and then this C2H3O2, and it's like, what's going on? There's like so many options here, too many elements. That C2H3O2 is acetate. It's a polyatomic ion. So we would just call that thing silver acetate. Okay. Any other questions from this page?
What exactly, because I missed putting it in my notes somewhere, classifies something as a type 1?
Is a type 1. Type 1 will be anything that has a predictable charge. So like the things that are in column 1, column 2, aluminum in column 3, and then zinc and silver in the transition metals.
Okay, yeah, I had those circled. I don't.
Yeah. Then all the other things, so all the transition metals and the lanthanides that are like the bar underneath, those are all varying charges. So yeah, we would classify those as type 2.
Okay, thank you.
Number 24 down here, let's take a look at this one. See how it says SO3? There is no charge in that. It doesn't say SO3 2-, it says SO3. So when we're looking at that, we are not looking at the polyatomic ion sulfite. Okay, sometimes people will want to write sulfite for that one, but there's no charge. When there's no charge, we're going to treat it just like we would a normal molecular. So we're going to use prefixes. So we've got sulfur trioxide. Sulfur trioxide. Okay, I'm going to leave this page for a minute because I want to just get a little bit on the third page, which is going from the name to the formula. And I want to, make sure that we're all good with how to do that. So Elizabeth, you are so awesome. Thank you for sending this to me. You're not gonna let me move you around, are you? Okay. So on this one, we are given, why is it not letting me? Nothing is working today. This gives you the name. And you've got to come up with the formula. I need this back, honey. Here, you can play with that. So for this very first one, we've got, I'll write the first couple. Okay, barium chloride. Next one, lead 4. Chlorate. And we've got chromium. Nitrate. This is 1, 2, 3, and then I'm going to skip a couple down. Let's do number 8. Okay, so you will find that you like one direction better than the other. You may like the other page better. I find that actually these ones are a little bit easier. So you still want to be asking yourself, okay, what is this? Because you need to be able to do charge balancing if it's ionic. So the first one, barium chloride. Now, barium is a metal, and it's specifically a metal with a predictable charge. So this is an ionic type 1. Chloride is talking about the element chlorine. So no polyatomics or anything here. So it's just an ionic type 1. So what I need to do is write the name of my metal, or the symbol for the metal with the charge, 2+, and then the symbol for the non-metal with its charge, and then flip-flop. So I get BaCl2, barium chloride. What I see here as far as like 60% of the class, like clockwork, when I just let them kind of go off and work on this, is they will see this and they go, oh, okay, BaCl, done. They take barium and they take chlorine and they just smush it together. The problem with this is it's not charge balance. So always make sure you're balancing charges when you have a metal combined with a non-metal. This second one here, lead 4 perchlorate. This is ionic. It's type 2 because it gives me the charge, so it has an unpredictable charge. And then perchlorate, anytime you see ATE or ITE, that is a polyatomic, okay? It's not one that you see quite often, so just look it up. So the charge on lead, PB, what is the charge on lead? You're not gonna find it on the periodic chart. You're gonna find it right here. That's why they give it to you, because otherwise you wouldn't be able to pull it out of thin air. Perchlorate, I will give you, is this thing called ClO4 with a minus charge. Okay, so 1 chlorine combined with 4 oxygens, and it has an overall negative charge. So we're gonna flip-flop. We're gonna flip-flop. I would circle your polyatomics though, so that you make sure to clump them together, because this 4 is gonna get dropped down to the outside of that perchlorate. So we're gonna have a 1 on the lead, PB, and then the chlorate, we need to put a 4 on the outside. Sorry, hold on a second. I'm trying to get her something. Okay, so the 4 gets dropped to the outside here. The 1 gets dropped to the outside here. Pitfalls I see with this one just regularly is people will see the 4 and then the 4 here, and they just sort of like morph that into 1 4. So they'll go PbClO4, and they're like, well, no, the 4 is right there. No, there's a 4 that's included in the polyatomic, and then there's the 4 that's coming from the charge. So make sure you're doubling that up. The next one here, chromium 3 nitrate. Okay, so chromium 3 nitrate, thank you so much all for bearing with me. We've got Cr with a 3+ charge. Where's the 3+ coming from? It's coming from the parentheses. So that's why if they were to have just written chromium nitrate, you wouldn't be able to come up with a formula because you wouldn't know the charge. Nitrate is NO3 with a minus charge. This is kind of similar to that one before where there's that like doubling up. So let's circle this, keep that thing as a whole. The 3 gets dropped down to the nitrate, the 1 gets dropped down to the chromium. So 1 chromium, and then we get nitrate, and we have to have 3 of them. Number 8, the reason I skipped over those ones is because I wanted to do one that wasn't ionic, right? I'm sorry, this is ionic, this is type 2, and this is also a polyatomic ion. This is molecular. When you get to molecular, there is no flip-flopping, there's no charge neutrality. All you do is write what it says. So carbon, there's 1. It doesn't say monocarbon because you can drop the mono on the first. So we have carbon, and then tetrabromide, tetra is 4. So we'll put bromine, and we put a 4, and you're done. Those are like, I think, easy peasy. Pitfall I see here is people want to go, oh, okay, so carbon, tetrabromide, so that means I have 4 carbons for every 1 bromine. They want to do the flip-flopping thing with 2 nonmetals. We're not doing charge neutrality, so this 4 is talking about the bromine. It has nothing to do with the carbon, so we don't like that one, okay? So take the prefix and drop it straight down to the subscript. The prefix is telling you what the subscript needs to be. Any questions on those? Okay, so I will then give you guys about, let's see, it's 10:32. I'm gonna give you 5 minutes to work on some of the ones on this page. And again, if you get to one that you get stuck on, just circle it and we can go over it as a class. So try and get through as many as you can. If you want, you can skip every other one or something like that so that you know, everybody does something a little bit different. And yeah, so I'll give you 5 minutes. So we will meet back. I've got 10:33 on my iPhone. So we'll go at 10:38. It'll give us a couple minutes to answer questions. Okay, so hopefully you're able to chew on a couple of those. Are there any ones you want me to expand on, go over? Just tell me what number.
Number 13.
Number 13. Okay, so the chromium 3 sulfate. So identifying what this is, it is ionic and it is type 2, and this thing over here is a polyatomic ion. So type 2 or type 1, you have to balance charges. So chromium, because it's a type 2, we're going to get the charge from here. So it's a 3+. Sulfate is a polyatomic ion, SO4, with a 2- charge on the whole thing. So I'm going to couple this together where the atoms are and leave the charge on the outside. And from there, we're going to flip-flop. So the 3 needs to drop down and the 2 needs to come over here. So chromium, there should be 2. And then sulfates, we will actually need 3 of those guys. Okay. So when adding up all the atoms in this thing, there are 2 chromiums, there are 3 sulfates, and there are in fact 12 oxygens in there. It's quite a few oxygens. Other questions?
Number 6.
16, you said?
6.
6. 6. Okay, copper 2 sulfate. So copper 2 sulfate. So yeah, these I definitely think are the hardest. These type 2s with polyatomics. So ionic type 2, and this over here is a polyatomic ion. So we need to balance charges. Anytime we have ionic, we want to balance charges. So Cu, the charge on it is 2+, right? You're not going to pull that off the chart. You're going to get it from here. Sulfate is a polyatomic, SO4, with a 2- charge. ATE endings, ITE endings indicate polyatomics. Again, I'm going to circle my polyatomic without the charge, just so I remember to keep that thing as a unit. Flip-flop, we should get Cu2SO4 but what do we do with ionics when we have something we can reduce? We reduce, okay? So we'll reduce that down by 2, and our final will actually be a 1-to-1, a CuSO4. If you only have one polyatomic ion, no parentheses. So we wouldn't put that in parentheses. Good with that one, Kayla? Kayla, sorry. Okay, other ones? Anyone out there? Even my people without cameras on that you want me to go over?
What
Just-
about number 10?
Number 10, okay. Oh yeah, that's a good one. Okay, ammonium carbonate. So ammonium is not something you will find on the periodic chart because it's a polyatomic ion. Carbonate is also a polyatomic ion. So this is 2 polyatomic ions. You're not going to see this very often, but on occasion you will. How are you going to treat a polyatomic and a polyatomic? Well, because they're both charged particles, treat it like an ionic. Okay, treat like ionic. Or you're going to need to charge balance. So ammonium is this thing, NH4 with a plus charge. It's like one of the few positively charged polyatomic ions you may come across. Carbonate, CO3 with a 2- charge. I'm going to circle my polyatomics without the charge. And then we're going to go ahead and flip-flop. So the 2 is going to be focused on the ammonia. The 1 will be for carbonate. So NH4 with a 2 around it, and then carbonate, CO3, and we only have one of them. Elizabeth, is that clear? Clearer? Yeah, great. Okay, good. Any other ones? I can probably get one more in.
What about number 15?
15. You said 15, right?
Yes.
Okay, yeah, 15, trisilicon tetranitride. Trisilicon tetranitride. Okay, so this is different than the ones we were doing before. This is molecular, okay? Meaning that there's no charge balancing. We're going to use the prefix to tell us how many of each we have. There's no polyatomic ions. This IDE is referring to nitrogen. So trisilicon means that I have silicon, and specifically we have 3 of them. So this becomes the subscript. Nitride is nitrogen, and tetra is the prefix for that is 4. So 4 nitrogens. Is that clear? Whoever asked that?
Yes. Thank you.
Okay, awesome, awesome. Okay, any other ones that you're dying for me to go over?
I have to count. Hello.
Hey,
Good. Hold on one second. I'm gonna better because I'm on a Zoom for chemistry
yeah,
too.
Kayla, we can hear you. Anybody else want any other ones? Trying to see if there's anything in here. Okay, so again, if you want me to look over your lab before you turn it in, just to make sure that you're like really spot on with it, I can sort of do a pre-grading for you on if you get it to me by like Saturday afternoon. Otherwise, I'll just grade it how we normally would. Okay, well, thank you all so much for bearing with me and enjoying this crazy morning with my kids and my dogs and everything. Hopefully next time I'll have my sitter. It's amazing. Childcare is just so important. Kids in school is so important, and I can barely get anything done. All right, if you have any personal questions or one-on-ones, stay around. Otherwise,